Hello, this is Moses Wan, and welcome to part 8 of my MATLAB tutorial videos. In this video, I am going to show you how to do root finding through bisection method and how to program that into MATLAB. So, let's start with telling you what root finding is. Root finding is basically finding the roots of a function. So basically finding when a function equals 0. So the green lines are function, all the red dots are our roots. Sometimes the math for figuring out the roots is pretty easy, but most of the time you'll find yourself with equations that just aren't really easy to solve. So what bisection does is basically scans between 2 points and narrows down where the root is. So how does it do this? So basically, let's say we've got function here again, and we're going to say our root's going to be in between here and here. So how bisection does this is basically evaluate the middle point, check whether it's in between this here or here. If it is in between here or here, evaluate that section, find the midpoint, check if it's here or here. If it isn't, then just do the other side instead. So screw that part, do the other side instead, find the middle point, and it'll keep going until that midpoint is close enough to the root. So how do we know where the root is? So basically we've got our x-axis and we've got our function. So you see every time it crosses 0, it's always changing signs. So basically what we can do is find from here to here, find what this point is and the value of this point, times them together. If they are negative, then that's what the root's in between these 2 points. Because if you think about it, if you try and go in between here and here, if you times the two numbers together, you get a positive value because negative times negative equals positive. So we know the root isn't there, and we can clearly see from the graph it isn't there. And similar case for when it's up here. Let's say we take these two intervals. Positive times positive will always equal positive. So if you times the two intervals together, if they're positive, the root's not there. If it's negative, it's always there. So let's try program this in MATLAB. So before we program, let's try to show you what we're going to try program. So function, first of all we need our function, and we need our two intervals. So I've named the two intervals the x lower and the x upper. So now between these two we're going to evaluate for the midpoint. So it's just the average between these 2 points. So this plus this divided by 2. Now it's time to run our loop. So we're going to ask ourselves, when we get this point and times it together, is it negative? So if we times f mid by f upper, does it equal negative? So in between here. If it is, then we're going to make the lower limit equal to that middle point and then reevaluate itself again. If it isn't, then we're going to make the upper limit here and reevaluate for this section and then find the middle point. So we want to keep looping this until x mid, when you sub it back into the function, it's close enough to 0. So let's show you the program for this. So I've basically made a function that is y equals x squared. Well, I mean x squared. So I've made my function for this that is x squared minus 6. So I've defined my lower limit as 0 and my upper limit as 5. And I've evaluated for x mid, which I have here. So I'm going to put all this crap in here into a loop. So we want to do a do while. So while the absolute value of this point is greater than 0.01. So we don't want anything which is greater than 0.01 or less than negative 0.01. So if it is greater than 0.01, then just run this loop until x mid, when you substitute that in, this equation is proven false. So that means it's in between negative 0.01 and 0.01. And then we'll just print it out as our result. So that's basically how our program goes. But I've made another program which shows you actually what the hell it's doing. So let's run this program. Okay, so we've got our program running, and so this is just a graph of x squared minus 6 from 0 to 5. So we've made our lower limit 0, our upper limit to 5, and we've evaluated the midpoint. So our lower limit is 0, our upper limit is 5, and we found the point in between, which is 2.5. So we've put in 2.5 into the original function, and it turns out to be 0.25, which isn't what we want here because it's not close enough to 0. So we're going to run through this loop again. So since 0.25 when we sub it in is positive, and then when we sub in 5 into here, which is positive, positive times positive equals a positive number, which is greater than 0. So this condition is proven false. So we're going to make the upper limit equal mid. So basically now we've made this the upper limit and this the lower limit. So we're focusing between this section, 0 to 2.5. We found the midpoint again, substitute it in to the function, and now it turns out to be worse than before. So it's now negative 4.43, which is nowhere near our condition, nowhere near 0. So now we run through that again, and we keep looping back and forth until we get closer and closer. So here to here, we've made x mid is now lower, here to here. So now x mid is made lower again, here to here, x mid made lower again. And it keeps going. As you can see, these intervals keep narrowing down until it's very minute. And then we take half, and this time when we substitute it in, it's in between negative 0.01 and 0.01. So we'll just make that our root. So that's how we do bisection method in MATLAB. If you have any questions, just contact me. I know this is quite a hard concept to grasp, so yeah, if you need help, just contact me. Thank you.